Alright, let's attempt this problem. A modern artist throws a bottle of paint towards the wall of a nearby building. The bottle leaves the artist's hand at a height of 2 meters, a speed of 16 meters per second, and at an angle of 30 degrees above the horizontal. If the building is 15 meters away, A. At what height h does the bottle hit the wall? And B. At what velocity v is the bottle traveling at as it hits the wall? Okay, so before we attempt either part, it's always good to draw a diagram explaining what you're doing. So let's draw the ground first. And we'll draw the wall as well. How far, or actually the artist now, just draw him as a stick man. And he's holding that bottle of paint, right? At what height is he holding the bottle of paint at? He's holding at a height of 2 meters. And he's how far from the building? This distance is 15 meters. And he throws it like this at an angle 30 degrees above the horizontal. And he throws it at a speed of 16 meters per second. And you can imagine his throwing, like his throw, it would look something like this, right? But the point it hit it at, it could be down here, but it could be up here as well. We don't really know that. We want to figure that out, right? That's what part A is asking us. At what height h does the bottle hit the wall? Alright, let's look at our equations. So we're looking for the height it hit the wall at. We definitely need D, right? We need D. So we're thinking of which equation we want to use. If we use this one here, this D, we're looking for the vertical height. So we're looking for D, and that equals the average velocity. What's the average velocity? You need the initial velocity, which we have, and the final velocity. So we don't really have that, and we don't have the time either. So that's bad. And how about this one? We need the vertical height. We're looking for h, remember? At what height the bottle hit the wall? The initial velocity, we have it, but we don't have t. And a would be a part of the equation. How about we look for the point in terms of the horizontal velocity, where it hit the wall, and then from there we can find the time it hit the wall at, and from there we can figure out the height at which it hit the wall at. So if you remember, the distance horizontally is 15, right? So we're subbing 15 equals, and let's use this equation, because remember we don't know the final velocity. So VIT plus half A. What's A? What's A? It's 0. Because there's no horizontal acceleration acting on the object. We've only got the vertical acceleration of gravity. Otherwise, we don't have any horizontal acceleration. That's times t squared. So this term cancels out. So we're looking for 15 equals VIT. T equals 15 divided by the initial velocity. So this t will give us, think about it, this t will give us a time at which the bottle has hit the wall. And VI, well, if you remember, our initial velocity was 16 meters per second at an angle 30 degrees above the horizontal. So now we've got two forces. We can split the velocity into two forces, the vertical velocity, or sorry, this is actually the horizontal one. This is the horizontal velocity and the vertical velocity. This part here is 16. So what's h? H, well, we use SOHCAHTOA. So sine, oh no, we need cos for h. Cos 30 equals adjacent over hypotenuse. Our adjacent is h, our hypotenuse is 16. So h equals 16 cos 30. And if you use the sine, you'd find that v, the initial vertical velocity, is 16 sine 30. Now don't get confused by this v and this v over here. This is the initial velocity, and this is just the vertical velocity I'm looking at. So both of these make up the initial velocity. This is in terms of the horizontal. This is the horizontal initial velocity, and this is the vertical initial velocity. Which one are we going to use? This one. So we know now t equals 15 over 16 cos 30, and that equals about, I'm going to put it in my calculator, so 15 over 16 cos 30, and that is 1.08 seconds. So this is the time the bottle will hit the wall. So now we need to find at what height does the bottle hit the wall, and we can use this equation again. We're looking for d, which in this case equals h, because that's the height it hits the wall. So I'm just using a different name for it, h, and that equals the initial velocity. What's the initial velocity this time? Because we're looking at the vertical one, so it'll be this one right here. So h equals 16 sine 30 times t, which is 1.08, plus half times the acceleration. What's the acceleration? Negative 9.81, that's gravity. This time it's not 0 because we've got a vertical acceleration acting on us, whereas the horizontal acceleration doesn't exist. And finally 1.08 squared. And this equals, it's going to take me a second to put in the calculator, 16 sine 30 times 1.08 plus half negative 9.81 times 1.08 squared. And this equals about 2.92 meters. That's the height at which we hit the wall, but we're forgetting something. Because remember, he threw the bottle at 2 meters above the horizontal. So it's actually 2.91 plus 2, and that equals 4.91. And that's what h is. So that's the answer for part A. Let's mark it here, h equals 4.91 meters. Our velocity v is the bottle traveling at as it hits the wall. Okay, so we go back to our formulas. We're looking for the velocity it hits the wall at, the final velocity. I think this one works, right? Delta v equals at, so vf, v final, minus v initial, equals acceleration times t. Now the thing is though, remember our velocity, it's two components. It's the horizontal component and the vertical component. So to find our final velocity, we're going to need both components. So let's think about this. What's our horizontal component of velocity? What will that equal to? Well, since there's no accelerative forces acting on it, it'll actually be the same. It will stay as h. So our final velocity in terms of the horizontal velocity, so v final horizontal, equals 16 cos 30. So we can draw the final velocity as an arrow. Looks like this. This is 16 cos 30. And we've also got a final vertical velocity, and we can use that formula to figure out. So Vf, and what was our initial vertical velocity? It was 16 sine 30 plus acceleration times t. So our t was 1.08, and that's multiplied by the acceleration, which is negative 9.81. Let's put that in the calculator. 16 sine 30 plus 1.08 times negative 9.81, which is about negative 2.59, just say 2.6. Okay, and what does it mean that it's negative? It means that our initial velocity was pushing the ball up, right, at a pace of 16 sine 30. Now, after a while, the gravity force acting on the ball is actually forcing it down at a speed of negative 2.6 meters a second. So that was 16 cos 30, and this one is the vertical velocity acting on the object, which was negative 2.6. And now we want to find that final velocity where we combine the two, remember? Which looks something like this. So just move this vertical velocity arrow over to here, it just means the same thing, right? So now we've got a nice right angle triangle, and to find our final velocity, we'll just use Pythagoras. So VF equals 2.6 negative squared plus 16 cos 30 squared. Let me take the square root of that. In the calculator, 16 cos 30 squared plus negative 2.6 squared. We take the square root of that. So our final velocity equals 14.1. And remember, velocity, this is actually our speed, meters per second, but velocity is also our direction. So how can we find this angle right here, theta? Well, we actually use tan. Tan theta, it equals SOHCAHTOA opposite over adjacent, which is negative 2.6 over 16 cos 30. Negative 2.6 over 16 cos 30. Oh, we have to convert that to radians. Yeah, so tan theta equals negative 2.6 over 16 cos 30. So theta equals tan inverse, it's just on your calculator, negative 2.6 over 16 cos 30, which equals negative 10.6 degrees. So why it's negative? Because the angle is actually below the horizontal, right? It's below the horizontal. And so that's our angle, right? You actually just put it, I guess you explain that it's a negative angle, yeah. So our final velocity is 14.1 meters per second at negative 10.6 degrees. Done.